Welcome. Let's look at some basics of functions. The most important basic thing is to recognize and remember that there's exactly one and only one output for each input. So we think of that as the x as an independent variable, and the y is the dependent variable. And when you put x into an equation, you get only one y back when you use it in a function. If you get two y's back, then it is not a function. Okay? And we'll actually go through some examples of that. Let's take a look at, for domain and range, what these actually, the various words and terms and meaning things, of which I've actually already started some up there. Right? So the domain are x values. The range are y values of a function. Another way to think of it is that the domain is the input and it leads to the output. And as I said before, it's the independent variable. You choose what to put in as the x value. And I'll write variable. But the resulting y value, it's dependent because you don't choose the y value. You choose an x value and you do an input and you get a result, but that result you don't get to decide. You only decide the input. Then you work all the things out in the equation. So it is called a dependent variable, because the y value depends on whatever you put in for the x value. Okay, now let's look at, to figure out domain and range, let's take a look at an example one. I'm going to use this here as like a little graph, and I'm going to put a, let's do a point about here. Let's make a little parabola. And this point is going to be -2, 3. That's the vertex there. Okay, so -2 and 1, 2, and 3. So what we're going to do is figure out what the domain is, what the range is, and remind you about the different ways to write it. So right now, what we can see is all along here, every x is going to be used on this parabola. The point here has an x. If this keeps going, which it's going to keep going all the way to -infinity, then every x is going to be used. And it's going to keep going this way to infinity. So I guess I'll put the infinities there. So one of the ways that we write this is that the domain is from -infinity, which is less than x, which is less than +infinity. However, we also want to use it in interval notation, and that's something you're going to use often, a lot. So from -infinity to infinity. If it's all real numbers, you can actually also say that, all real numbers. And of course, all real numbers has a symbol for it. Of all of these, the best way to write the domain is in interval notation. Okay, now for the range, we're going to do the same kind of concept. Okay, so first we start, let's do it with inequalities, and the range starts here at 3 and goes up. So here we can say that y is greater than 3, and it's also equal to 3 because that 3 is actually on the graph. And to do that in interval notation, we'd be going from 3 with a box bracket because it includes 3, going up to +infinity. We can't put the all real numbers part because it's not all real numbers, but we can do this part, the interval notation part. Now let's talk about the various ways that you can show a function. Okay? There are 4 of them. There's other ways you might be able to too, but these are the 4 basic ways that you can show a function. An equation, the basic equation of y equals mx plus b, or there are other equations, but let's use this one for now. And using the function notation, So let's actually do one where, say, it's f of x is equal to 3x plus 1. So that would be as an equation, okay? And generally, you should use, even though you're used to y, this is a good time and place to get used to using f of x for functions. Now, you can show a function in terms of a table. Let's put a few points in there, and let's start, let's just do, say, 0, 1, 2, 3. And if I put 0 in this place, I get a 1. If I put 1 in here, I get 4. If I put 2 in here, I get 7. And if I put 3 in here, I get 10. Now, you see that the difference in the y's is 3 each time. And the difference in the x's is 1. So this difference of 3 over 1 is your slope of 3. Now, I'm going to actually put these numbers, they're the main numbers, so put them in red to identify them, as that's the point of what we're dealing with. Now over here for mapping, let's put the domain numbers and then the range numbers, and it just so happens that they're across from each other. So the mapping requires using these arrows. Use the arrows. Now when we put the y's there, if these were not in that same order, we put them in numerical order from lowest to smallest, you might have one where it's going diagonal. And that would be perfectly fine as long as it's only one y for that x. So this one needs erasing because that 0 already has the y that goes with it. All right, now let's graph it. And so graphing that, the function of x is 3x plus 1. So here's my y-intercept. And so I'm going to go to a positive 1. And then I have a slope of up 3 and over 1. And up 3 and over 1. So when the slope is 3 over 1, rise over run, I can also make it negative 3 over negative 1 because those negatives would cancel to get the right numbers. But it enables me to go down 3 and over 1 towards the negatives, the other direction. That allows me to have more points for drawing the slope. And it all started because I had a good start for the y-intercept. I think that'll work. Reasonably decent line, even though I didn't quite go over that dot there. So those 4 ways of showing a function, you want to make sure you can do any one of them. Now let's look, just a reminder about function notation and evaluating functions. All right, and so if I said f of minus 5, that's just simply putting a negative 5 in that place. So we get negative 15 minus 5. So the function at negative 5 is equal to negative 20. And here, the only thing to remember is simply that that this side, get that there. Okay, this is nothing more than notation. It is not something to calculate. You leave the f and the minus 5 there. And I think you already knew that. I just want to make sure no one forgets. Okay. Now let's look at this other one over here. And I'm going to do minus 5 as well. And here I have an issue only with negatives, recognizing that that's negative, negative 5, negative 5. So these two are a positive 25, and there's still a negative out there, right? And then that's minus 35. So then here we get negative 25 take away 35 is equal to negative 60. So f of negative 5 is equal to negative 60 for that one. Now, let's take a look at something. I'm going to take the extra space that I wrote here, and I'm going to use this one. And this time I'm going to do it as f of x minus 3 equals, so instead of x, I'm going to use x minus 3. So what that means, if I'm going to do In place of the x here, I'm going to put the x minus 3. This I bring up. Oh, hold on a second. It looks like, I have some things that didn't show up on this page. Okay, and I'll go over it here. Well, you know what? I forgot that I had this here. So actually, I don't need this part yet. I also don't need this one, but I do want this one because I want to use the negative. So I'm going to do x minus 3, and we're going to put the x minus 3 in here. So what I want to focus on is what to do here. A common mistake made that I don't want you to make is to think of x minus 3 squared as x squared plus 9. So that would be squaring the x and squaring the negative 3. But that is not correct, because what that's doing is distributive property, and you're not supposed to distribute the two. Instead, remember that what an exponent is doing the same thing twice. So x minus 3 squared means multiplying x minus 3 times x minus 3. Now, when you work that out, you get x squared minus 6x plus 9, and it's that middle term that gives away whether or not you squared correctly. So now what we have is minus x squared minus 6x plus 9, and here we have 7x minus 21, so work that out. And this is the other thing, is remembering that that negative now is used as if it was a negative 1. You multiply that to everything in there. 6x minus 9 plus 7x minus 21. And then you combine the like terms. So the function of x minus 3 is equal to a negative x squared, because it's the only one that's squared. And these two can be put together for 13x, and then these two can be put together for negative 30. Let's take a look now at piecewise function. In a piecewise function, it means it stops somewhere, right? So right now, when I look at this, I know that if x is 5, I'm going to get a result of 3. But if x is not 5, I'm going to put a number here and get it. I can't use 5 here because it would give me a 0 on the bottom. I do see, however, that I can simplify this. So that is x minus 5 and x plus 5 divided by x minus 5. So those cancel out. So instead of all of this, I can use x plus 5 if x is not 5. That doesn't mean I can now put 5 in there and get 10. What that means, because of the fact that this still exists, that's still the main thing. I have to still keep this domain restriction. So now let's use it. Let's say I put 10 in. Well, 10, if I want x equals 10, I can't use that one because it's only, oh, wait a minute, I can. This is the one where I do 3 only if x is equal to 5. If x is not 5, then I use that. So that means I will do 10 plus 5, so 15. I've evaluated for 15. Now I put 5 in. Well, if I'm going to use 5, then I can't use this one. If x is 5, the answer is simply that 3. So the function of x is 3, or the function of 5 is 3. So I could say this, function of 5 is equal to 3. In fact, I'll say the function of 10 is equal to 15. Now when I put 0 in, the function at 0, so 0 doesn't fit this one because it's not equal to 5. It's not this one. However, 0 does not equal 5, so I would use this. So 0 plus 5 is 5. And when I put negative 10 here, I'll do the same thing. Negative 10. So this doesn't fit for negative 10 because it's not so, but this one is. Negative 10 is not 5. So I can do negative 10 plus 5, which is a negative 5. Okay, so there you just have to simply pay attention to the domain, which one of the categories you're supposed to be in based on the number that you're doing. Okay, now here's a different piecewise function, and let's take a look at what happens when we evaluate for 10. So f of 10, so let's see which one it is. 10 looks like it fits this. 10 does not fit this because it's not between those two numbers, and it's not less than negative 2. So that means we need to do negative 10 squared plus 4. So we're using this one. So 10 squared is 100. That's negative 100 plus 4. So that means the function at 10 is negative 96. Now the x equals 7. So here, that does not fit this because x has to be greater than 7. But it does fit this one. So that means I'll use this. So the function of 7 is 7 plus 1, or x plus 1. So the function at 7 is equal to the number 8. Now let's do 0. 0 is one of the numbers in between negative 2 and 7, so we'll use that. So the function of 0 is equal to 0 plus 1, or 1. Now negative 10. Negative 10 doesn't fit this one, and it doesn't fit this one, but it is true for this because it's less than negative 2. So the function of negative 10 is equal to 3 times negative 10 minus 15. So the function of negative 10 is, that's negative 30 minus 15. It looks like it's a negative 45. Oh, I meant to use different colors after the second one, but oh well, forgot. So looks like we've got 8 for one and negative 45. I guess I'll do green for that. I'm going to do it that way. And then do black for the last one. So it's as if I was doing different colors. All right. Now let's talk about domain. These are domain problems. So we're identifying the domain. Okay. So the domain is all the x's that we're allowed to have. So what x's can we have? Well, all real numbers unless there's some reason not to. And in this one, here's a reason not to. That cannot equal to 0. So we do x minus 4 equals to 0 to find that x equals 4. That 4 is what we cannot use. So therefore, we would say that the domain, okay, let's put it over here. The domain is x not equal to 4. That's one way to say it. But I want to do it with interval notation. All the numbers from negative infinity to 4 can be used. 4 cannot be used. And that's in union with starting from 4 but not including it up to positive infinity. This one shows that where you're going from negative infinity all the way to 4. I will put 4 down here. You're doing an open circle, and then it's continuing to positive infinity. Okay, so 4 is like the only thing not used, and both of those show it. But this is how you show it in interval notation, which is what I want people to get used to doing. And anytime there's an interval of possible answers, which there are, because all the answers up to 4 on both sides are possible answers, you use interval notation. Okay, now with the square root, the idea of that is what's underneath the square root cannot be less than 0, not less than 0. It can be 0. Being 0 is okay, because the square root of 0 is equal to 0. But the square root of negative 1 is imaginary, and so we don't use that in a function. You know, imaginary numbers are not real numbers, and functions have to be graphable. So instead, what we simply do is that the numbers for the domain are all the x's with as x plus 5, all the x's where it's greater than or equal to 0. So that means x greater than or equal to negative 5. So that's the domain in one way. But what I want is to put it in interval notation. And we're basically going from negative 5 to infinity. So this is the way that we would show it. Okay, so those are all the possible numbers that could be used that make that correct. So -5, -4, -3, good. -6 is not. Let's put them together now. In this case, sometimes putting them together, it doesn't make a difference. So first thing is 3x plus 12. 3x plus 12 cannot equal to 0. So let's find out what would make it 0. -12 minus 12. 3x equals -12. Divide by 3. 3 equals -4. So -4 is a number that would make this the square root of 0, and 1 over the square root of 0, well, that would be 0, square root of 0, 0, and you can't divide by 0. So that means x cannot be -4. All right. The next thing, so that's like one thing. We have to find out where it is not equal to 0, and we just did. The second thing, however, is that we have to make sure that what is in here is greater than 0. In other words, less than 0 wouldn't be good. Right now, if we didn't have the square root, then a number like -10, we'd have -30 plus 12 would be, -18. And 1 over -18 is -1 over 18. That's a perfectly valid number, except that in a square root, we can't do, and must be greater than, okay. I'm not going to write it that way. I'm going to erase that part there. So we're going to say square root of 3x plus 12. That whole thing must be greater than 0 or equal to 0. Okay. So all we have to do here then is take 3x plus 12 and make that greater than equal to 0. Because if we had a negative there, if this became, if this was -5, we get a -3 result, and square root of -3 is imaginary, throw it out. So let's do it this way, and let's actually calculate what it would be. -12 on both sides. 3x greater than or equal to -12. Aha! So it actually is very similar, greater than or equal to -4. Now the difference is, so that means we have to be greater than -4. But this, normally, if it wasn't in a denominator, that square root thing would allow us to be equal to -4. So putting these two things together means that we would simply say that the domain is x is greater than -4, but not equal to -4. And in interval notation, we go from -4 with the parentheses to infinity, which is the best way to show the answer for this. And with that, I think I will put a box around these. Okay. And that's it for showing the domain. You can't be dividing by 0, but you also can't have a square root where it's a negative number. And sometimes they combine so that you can't even use the -4 itself in this case. I hope that helps with this section a little bit. Thank you for watching and listening.